Okay, so this is 13.2 theoretical probability of compound events. Again, we are not actually doing it. We're not doing the experimental. We're not actually doing the simulation. We are just theoretically thinking of these events happening, okay? And your objective to be able to find the probability of the compound event theoretically, and then so we'll do different examples. One of them is finding probability of A and B. That means a compound event of the two things happening using a table. So this one is, what is the possible ways to roll a sum or addition of 4 by rolling 2 dice? So if we were to roll 2 dice, what would be the possibility of getting a sum of 4 when I put them together? So let's do this. I'm gonna do 1 plus 1 is 2, 1 plus 2 is 3, and I'm gonna keep on going. Okay, so I'm finished with that table, and we want a sum of 4, so I'm gonna circle the ones that add up to 4, and then, oh sorry, this is not it. So it's 1, 2, 3. 3 out of how many? What is the total possible outcomes? Okay, so this is the number of total possible outcomes. So it's going to be 6 times 6, 36. So that's 3 out of 36. And I have to simplify that by 3 to end up with 1 over 12. So that would be the possibility of getting that. Okay, go ahead and give me the possibility, the probability of getting a sum of 7. Simplify it if you can. Okay. Here we go. And then this one, we're going to do probability using a tree diagram. So in this case, we have two options of a waffle or a regular cone. We have flavor vanilla, chocolate, or strawberry. So it can be vanilla, chocolate, or strawberry. And then we can do either sprinkles or nuts. Okay. So first I'm going to do waffle and regular. And then I'm going to give the flavor to each one of those. So that's vanilla, chocolate, or strawberry. Vanilla, chocolate, or strawberry. And then I can do sprinkles or nuts. So sprinkles or nuts, each one of them. The first thing we want to see is what are the total possibility of getting an ice cream with having 2 different cones, 3 different flavors, and 2 different toppings. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. Okay, and the probability that it's asking me is vanilla flavor. Okay, so I have vanilla flavor right here. And I have vanilla flavor right here. That's 1, 2, 3, 4. So that's 4 out of what? 12. I can simplify by 4, and I get 1 out of 3. Okay, so or 33 hundredths repetitive, or 33%. Okay, so the probability of that. Now for the nut, this one has nuts, this one has nuts, 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 and nuts. So 1, 2, 3, 4, 5, 6. So 6 out of 12, that's half. That's 5/10 and 50%. Okay. The easiest way to actually do that without doing the diagram is you multiply the different items that you have. So you have 2 different cones, you have 3 different flavors and 2 different toppings. You go 2 times 3 is 6 times 2 is 12. Okay, go ahead and tell me the probability of getting a vanilla or chocolate ice cream cone. Okay, here we go. Last one right here. This one is we're gonna use a list. Okay, so we have a lock combination, and the question is what the probability of getting code 22 is a 2-digit code using numbers 1, 2, 3. Okay, so let's do that. So I can get 1, 1, 1, and I can either do 1, 2, 3 there. I can be 2, 1, 2, 2, 2, or 3, 3, 1, 3, 2, 3, 3. Okay, so there are 2, 2. There's only one of those. Okay, so that's 1 total. Out of how many I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So a total of 9. So that probability is 1 over 9. Okay. The decimal will be 1 repetitive, or 11%. Okay, go ahead and tell me what's the probability of the code ending. Alrighty, God bless you. Bye.